differentiate h of x equals cosine of the whole fraction 1 minus e to the 3x over 1 plus e to the 3x. Okay, now we're getting spicy with these problems. We've got cosine of something that's quite complicated. We actually notice that this is a quotient, so when we take the derivative of the inside, we're going to have to use the quotient rule. But before we even get there, we have to use the chain rule because we've got the composition of cosine with all of this. So, using the chain rule, we're going to have to differentiate the outer function first. The derivative of cosine of u is negative sine of u. So we're going to have negative sine of all of that. On the inside, that's going to be 1 minus e to the 3x over 1 plus e to the 3x. And then we have to multiply that by the derivative of the inside. And I'm going to write that as d over dx of that whole inside. The reason I'm going to do that and wait until the next step to differentiate that is because we have a quotient here, and so we're going to need to use the quotient rule on that. So we're done with the first part. We've differentiated the outer function, but to differentiate the inner function, we're going to need to use the quotient rule, and when we do that, when we're differentiating the insides, we're going to have to use the chain rule on these e to the 3x's. So it's going to be a fair bit of work, but I think after having gone through several examples, we're at the point where we're going to be okay with this. So we're going to keep this negative sign of all of that out front. I'm just copying that down now. And then we have to use the quotient rule for the latter half. Remember, the quotient rule tells us we have low d high minus high d low all over low squared. So we've got low d high. Well, the lower function is 1 plus e to the 3x times the derivative of the higher function. The derivative of 1 is nothing, so we can ignore that, but we need the derivative of negative e to the 3x, and this is a composition of functions. The outer function, ignoring the negative, we're going to hold on to that negative for a minute, but the derivative of e to the u is e to the u, so we're going to have negative e to the 3x, but then we have to multiply by the derivative of u. The derivative of 3x is 3. And then from there, that's low d high. Now we've got to subtract from that high d low. So the higher function is 1 minus e to the 3x times the derivative of the lower function. The derivative of 1 is 0, so we can ignore that. The derivative of e to the 3x, we're going to have to use the chain rule. The derivative of e to the u is e to the u, so that's going to be e to the 3x times the derivative of 3x, which is 3. Whenever we're differentiating e to a constant times x, we basically get that constant multiplied by that power of e. Basically, the constant pops out. So that's something that we will see many times, and the sooner that you get comfortable with that, the quicker and easier things will be. And then, of course, in the denominator, we have low squared. So that's 1 plus e to the 3x all squared. And then in the top, we've got to figure out what's going on. If I look at these two parts, there are a couple of things that it looks like we can factor out. We've got an e to the 3x in each of them, and we've got a 3 in each of them. So we should be able to factor those out. And in fact, there's a negative on this whole first bit, and then this second negative goes on the whole second bit. So we can factor out those negatives as well if we want. Now, I'm going to copy that first sign bit, because that's going to stay the same. And then let's factor out those things that I mentioned we could factor out. The 3's, the e to the 3x's, and the negatives. So we've got a negative 3e to the 3x that we're going to factor out. And when we do that, in the first one, we factored all of this out, and we're left with 1 plus e to the 3x. And then for the second bit, we factored out the 3e to the 3x and this negative here, and so we're left with 1 minus e to the 3x. And that's going to be positive, because we factored out that negative earlier, all over 1 plus e to the 3x squared. And if we look at the numerator, there's a little bit of canceling that we can do. We've got a positive e to the 3x and a negative e to the 3x. And then we're left with 1 plus 1, which equals 2. And when we multiply that 2 into this, 3 times 2 is 6. We also have two negatives that cancel. The negative out front and the negative here get multiplied to become positives. So many things going on at once. So we end up with this sign of 1 minus e to the 3x over 1 plus e to the 3x. And then times, we're going to have 6e to the 3x, because remember we had the 1 plus 1 is 2, and 2 times 3 gives us that 6. And that's all going to be over 1 plus e to the 3x quantity squared. So this one ends up being significantly more complicated because in our composition of functions, we have a quotient that we need to use the quotient rule to differentiate. That quotient rule is always going to make things a lot more complicated.